What's up guys, this is Engineer Jack. So today, this is our course overview of the subject Geotechnical Engineering 2. We have two branches of Geotechnical Engineering, the Soil Engineering and the Rock Engineering. Soil Engineering is the application of the principles of soil mechanics to practical problems, and Rock Engineering is the application of the principles of rock mechanics. Syempre sa curriculum natin, walang Rock Engineering, yung meron lang Soil Engineering. Soil mechanics is the branch of geotechnical engineering that deals with the physical properties of soil and behavior of soil masses subjected to various types of forces. It applies the basic principles of mechanics, including mechanics of rigid bodies, statics and dynamics, yung Mech 1 and Mech 2 natin, fluid mechanics, and the mechanics of materials or the strength of materials to soils. So these are the applications of geotechnical engineering: foundation engineering, tunnel engineering, dam engineering, retaining walls, slope stability, geo-environmental engineering, pavement engineering, earthquake engineering, geosynthetics, and geothermal. Yung naka-highlight na kulay pula, yung foundation engineering and retaining walls and slope stability, yan lang yung pag-uusapan natin dito sa Geotechnical Engineering 2. All civil engineering projects like buildings, roads, bridges, dams, tunnels, and water tanks are all constructed on or in the ground. So, parito nito guys, usually ito yung mga constructed civil engineering projects natin. Yung construction on the ground, pareho ng dam embankment and road embankment and this structure. These are all constructed on the ground kasi nakapatong sa ground. And yung project naman natin na usually constructed in the ground, yung building foundation, supported excavation, and offshore foundation. So, as you can see dito, itong part na to, this is constructed on soft soil kasi this is saturated soil kasi malapit siya sa bodies of water kaya soft yung soil niya. So usually yung pag-uusapan natin dito sa geotechnical engineering, yung project na constructed in the ground. So pareho nito, usually yung building foundation na meron tayong footing, mga ganun. So yan yung pag-uusapan natin dito sa subject. So, what do we know so far? We all know that geotechnical engineering is a subdiscipline of civil engineering that involves the interrelationship between the geological environment and the works of man. The engineer doing this specific type of work is called a geotechnical engineer. In the first part of soil mechanics or the geotechnical engineering 1, you learn the phase relations, the relationship between solid, water, and air, consistency limits and indices, classification of soils, meron tayong silt, clay, and sand, soil compaction, ito yung eliminating the air voids in the soil. So, tinatanggal natin yung air voids, that's compaction. Pinag-aralan nyo din yung flow through soils, permeability and seepage, or the velocity of water in the soil. Principle of effective stress, ito yung dinadalang na stress ng solid ng soils. Stresses in soil masses. So with what we have learned in Geotechnical Engineering 1 as a background, we now can go to the discussion of the fundamental behavior of soils, particularly its strength and deformation, and then applying this in the solution of some practical problems of which in this course we'll cover. So ito na mismo yung Geotechnical Engineering 2 na yung cover, for example, the slope stability, lateral earth pressures, and retaining walls. So, yung sa course coverage ng subject, yung first part, the compressibility of soil, shear strength of soil, triaxial test of soil na kasama niya sa shear strength, soil stability, lateral earth pressure, and the soil bearing capacity. Yung second part natin dito sa subject, usually the reinforced concrete design of footings. So, sa compressibility of soil, so settlements at working loads must not cause damage or yung working loads natin dito, kasi di ba sa design natin, wala tayong, yung working loads, these are actual loads. Hindi siya factored load. So, sa actual load pa lang o sa working loads, dapat hindi mag-cause ng damage at hindi din maka-apekto yung serviceability of the structure. Or, syempre, dapat walang cracks. We have possible settlements, yung uniform, differential, intermediate, and long-term consolidation settlement. So itong picture na una, this is no settlement. As you can see, this is a 3D frame and hindi siya nag-settle or hindi siya nag-deflect yung soil, walang settlement. Yung second pic, this uniform settlement. As you can see, nag-deflect or nag-settle yung foundation pero uniform. And yung third pic, this differential settlement or yung partly, may part lang nag-settle, itong frame na to, ito yung part na nag-settle. Uniform settlement is usually of little consequence in a building, but differential settlement can cause severe structural damage. So, pareho nito guys, yung una, this uniform settlement, no cracks, and yung pangalawa, nag-tip or nag-tilt yung structure natin. Kadalasan daw walang cracks, pero usually nagkakaroon din yan because of time. Then yung third picture, yung differential settlement, itong part na to nag-settle ang soil, kaya nag-create ng cracks sa structure, pero partly lang. Pero with time, pwedeng mag-collapse yung structure natin. Yung soil natin, meron din siyang shear strength. This is usually the behavior of the soil when subjected to a force, and ito yung behavior ng soil natin. So, shear strength is a term used to describe the magnitude of shear stress that a soil can sustain. The shear resistance of soil is a result of friction and interlocking of particles and possibly cementation or bonding at particle contacts. So, pag-uusapan naman natin yan dito guys, pero sa ngayon, overview muna tayo or the course overview of the subject. This is the slope stability of our soil. So, as you can see, pag hindi na kaya or saturated yung soil, pwedeng magkaroon tayo ng landslides. Just like this second picture na natabunan yung roads natin, no? So, slope stability is the process of calculating and assessing how much stress a particular slope can manage before failing. So, i-solve natin yung stress before failure. So, hanggang saan ba kaya ng soil na ma-retain niya yung slope niya. So, this lateral earth pressure of retaining walls, just like this one. Ito yung part na retaining structure natin. And dito sa second pic, ito din yung retaining structure natin. So, retaining wall is a structure that holds or retains a soil behind it. So, in-retain niya yung soil. So, yun yung first part ng subject natin. Ngayon, this is the foundation engineering or the second part of the subject where we design our foundation footings. So, foundation engineering is an art of selecting, designing, and constructing the elements that transfer the weight of the structure to the underlying soil or rock. The role of engineer or the civil engineer is to select the type of foundation, its design, and supervision of construction. So, tayo magre-recommend ano bang type or the best type of foundation na pwedeng gamitin natin depending of the situation or yung situation ng soil. A properly designed foundation is one that transfers the structural load throughout the soil without overstressing of soil, which can result in either excessive settlement or shear failure, both of which can damage the structure. So, hindi lang tayo na basta-basta nag-design ng structure or reinforced concrete design. So, dapat talaga kailangan natin aralin yung behavior ng soil. Ano bang strength niya? Ano ba yung deformation nila? So, we have two classifications of foundations. We have the shallow foundations and deep foundations. Yung shallow foundation is a type of building foundation that transfers building loads to the earth very near to the surface. So, syempre, yung kabaliktaran niya, yung deep foundation. A deep foundation is a type of foundation that transfers building loads naman to the earth farther down from the surface. So, we have different types of shallow foundations. These are spread or isolated footing, strip foundation, mat or rough foundation, and combined foundation. Note, shallow foundations are usually reinforced concrete structure. Reinforced concrete kasi ito yung pinaka-most economical na material na kung gagawa tayo ng foundation. So, yung a spread footing, also called an isolated footing or pad footing or an individual footing, is provided to support an individual column. Kaya nga naging isolated siya kasi every column isang spread footing. So, ang spread footing is pwedeng circular, square, or rectangular slab of uniform thickness. Sometimes, it is stepped or hunched to spread the load over the large area. So, itong picture, usually, yung ginagamit natin, yung pad footing, hindi yung step footing or slope kasi yung pad footing yung pinakamadaling i-construct. We have also a wall footing or strip footing. It is a continuous strip of concrete that serves to spread the weight of load-bearing wall across an area of soil. So ito yung strip footing. Yung wall niya pwedeng concrete or this structural wall, pwedeng load-bearing or pwedeng non-load-bearing wall or pwedeng masonry, yung concrete hollow blocks with plaster, mga ganun. We have also a rough foundation. It is a reinforced concrete slab under the hull of a building or extension, floating on the ground as a raft floats on water. So, para siyang raft on the water, and this type of foundation spreads the load of the building over a large area than other foundations, lowering the pressure on the ground. So, usually, ginagamit natin yung raft foundation pag yung, lalo na kung ang structure natin napakabigat yung dadalhin niyang load, gamit na gamit to especially kung yung structure natin is a commercial building. We have also combined footings. These are constructed for 2 or more columns when they are close to each other and their foundations overlap. Nangyayari to guys, especially kung malapit nga yung dalawang columns or malapit na yung isang column sa property line. So, ang ginagawa natin na solution, kinukombine natin yung footing ng 2 or more columns. And these are the different types of deep foundations. We have pile foundations, caissons, and basements. A pile foundation is defined as a series of columns constructed or inserted into the ground to transmit the loads to a lower level of subsoil. So, ito yung example ng pile foundation. We have a column, pile cap, and ito yung piles. So, yung pile foundation natin, pwedeng bearing pile or friction pile. Yung bearing pile, yung piles natin is driven and aabutin niya yung hard strata or the bedrock. So, ito na yung magdadala ng load ng pile. Ang tawag dito is bedrock. We have also friction pile na yung magre-resist ng load na dinadala ng piles is the friction of the soil. Kaya ang tawag sa kanya is friction pile. Yung piles natin, pwedeng steel. As you can see, this is a W section of steel or I-beam. We have also caissons. Caissons is a large watertight chamber open at the bottom from which the water is kept out by air pressure and in which construction work may be carried out underwater. Usually used for construction piers of a bridge foundation. So ginagamit natin to, especially kung we are constructing the foundation of our bridge. So, syempre, para makagalaw tayo underwater, kailangan natin ng chamber na watertight, tapos tatanggalin natin yung tubig. Then tawag na nga dun is caissons. And basement foundation. Yung basement foundation is the load-bearing portion of the structure, typically built below the ground. It is an 8-foot or deeper hole that ends in a concrete slab. And any foundation must do 3 things well. Yung una, support the structure above, keep out the groundwater, and act as a barrier to water and soil vapor. So usually, yung wall na paikot sa basement is a structural wall kasi they is subjected to lateral loads because of the soil and buo siya with reinforcement kaya pwede din siyang tawaging shear wall and pwede natin lagyan ng waterproofing. Ito yung kulay pula na membrane. So yun. And thank you. Thank you for listening guys. Next topic natin is compressibility of soils. Thank you.